Hello everyone, welcome to my YouTube channel. My name is Mano and today we'll be doing the real number system. This video is my very first video guys, so I'm very excited and I'm hoping that you like my style of teaching. If you have any comments or questions or suggestions of how I might do some things better, please ask me in the comment section below. And please don't forget to like, share, and subscribe. Thank you. Let us begin. Real numbers are numbers which consist of rational and irrational numbers. These numbers can be plotted on a number line. So this means if you have a number and it can't be plotted on a number line, just know that it's not a real number. Okay. So the first thing that we'll look at is the rational numbers, and then we'll follow with the irrational numbers. Rational numbers are any numbers which can be written as a over b, where b is not equal to 0. And both a over b need to be integers, meaning your numerator and your denominator both need to be integers. So why is it that b cannot be 0? It's because any number divided by 0 is undefined. For example, if you have a 1 over 0, it will be undefined. If you have 1,000 over 0, it will be undefined. I've heard some people say because 0 is under, you can remind yourself that under and undefined, they correlate in your mind. I don't know if that's true, but you can do it like that also. Remind yourself that if 0 is under, then your answer will be undefined. You can even punch it in your calculator to confirm. Alright? Rational numbers consist of natural numbers, whole numbers, integers, terminating decimals, and recurring decimals. Natural numbers which are identified by symbol n are numbers which start from 1. So you will have 1, 2, 3, and so on. And then next we have whole numbers. Whole numbers are natural numbers but a 0 is included. So the symbol of whole numbers are n with a 0, right? So when you write them down, you will have 0, 1, 2, 3, and so on. I hope you all understand what I'm saying. And then we have integers. Integers are whole numbers and natural numbers combined, but then they include numbers before 0, which are negative numbers. So when you write them down, you will say, for example, -3, -2, -1, and then 0. See what I was talking about. Now we start with the whole numbers. 0, 1, 2, 3, and so on. I hope you all get my point. I wish I was teaching you live so that I can see where your mind is at. But for now, we'll just do it this way, okay? And then we have decimals. The first decimals that we're gonna do is terminating decimals. So to terminate is to end, isn't it? So terminating decimals are decimals which have an ending, meaning they do not go on, right? For example, you can have maybe 0.6, or you can have 0.8, that's it, or maybe 1.58, that's it. Just as long as they have an ending. I hope you all catch my point, guys. And then lastly, we have recurring decimals. So these ones have an infinite pattern, meaning they repeat indefinitely, right? So they have a repeating pattern. For example, you can have 0.565656 up until infinity, isn't it? Or another example, you can have 18.896, 896, and so on. The pattern keeps on repeating on and on and on, right? So for both of these decimals that I've given you, you should be able to see which ones have an ending and which ones do not. Alright, I'm so excited, guys. Next, let's look at irrational numbers. Irrational numbers are numbers which cannot be expressed as fractions where the numerator and denominator are integers. So it's the opposite of rational numbers, right? For example, square roots of numbers that are not perfect squares. Let me explain further. Square root of 2 or square root of 6 or square root of 8. But square root of 9, what is square root of 9? It is equal to 3, right? And the number 3 is what? It's rational. So that is why they say irrational numbers are square roots of numbers which are not perfect squares. And 9 is a perfect square. So it means a perfect square is rational. Another example is square root of 16, which is 4. It is also rational, isn't it? Next, irrational numbers are cube roots of numbers which are not perfect cubes. Why? Because perfect cubes are rational. Alright, let me explain further. For example, you can have a cube root of 2 or a cube root of 5 or a cube root of 9, right? Why not a cube root of 8? Because a cube root of 8 is equal to 2. So it's rational, meaning that 8 is a perfect square. So you cannot have a cube root of a perfect square, isn't it? That's why irrational numbers are square roots of numbers which are not perfect squares or perfect cubes, because perfect squares and perfect cubes are rational numbers. I hope you all get me. Alright, so we have looked at real numbers. We have looked at what? Rational and irrational numbers. So it's only fair that we look at non-real numbers, isn't it? So non-real numbers are simply square roots of negative numbers. If you punch non-real numbers in a calculator, it should give you a mathematical error. For example, you can, let's say, a square root of a negative 2. It's not a real number, is it? Or square root of negative 3. And so on. So as long as you have a square root of a negative number, it's a number that does not exist. Hence, they are called non-real numbers. Alright? So we have discussed all groups of rational numbers and of real numbers and non-real numbers. So I'll make a small table of different examples that we can look at. So please do it with me. Alright? Alright, so here are the few examples that I've made. You can even post the video and write them down and try to figure out if they're real or non-real. Okay. You can do so now. So it's fine also if you want to go along with me, to do it. All right. So let's start with the number 5. Is 5 a real number? Yes, it is. So tick it, meaning it's not non-real, right? Is it rational? Yes. So we'll cross irrational. Is it an integer? Yes, it is an integer. Is it a natural number? Yes. It is a whole. Is it a whole number? Yes, it is. Is it undefined? No, it is not. Okay, cool. And then we go to 0. Is 0 a real number? Yes, it is. Is it rational? Think about it. Yes, it is rational. Why is it rational? Because it's an integer, right? Is it a natural number? No, it's not a natural number. Remember, natural numbers start with 1. So they start from 1, 2, 3, and go upward, right? Is it a whole number? Yes, it is a whole number because whole numbers start with 0, isn't it? So it is not undefined. And then we have pi. What is pi? Pi is equal to 3,1415 and so on, right? So how is the pattern? Is it repeating? Is it not repeating? What's going on? So is pi real? Yes, it is real. Is it rational? No, it's not rational. Why? Because it doesn't have a repeating pattern, isn't it? So look at the pattern. It doesn't have a repeating pattern and it's not a terminating decimal. It goes on and on and on with different numbers all over the place, isn't it? So it cannot be a rational number. So go cross rational number. It is what? Irrational, and it cannot be written as a fraction, right? So if it is irrational, meaning simply it cannot be an integer, cannot be natural, it cannot be a whole number, but it is not undefined, right? And then we have square root of 9. What is square root of 9? It's equal to 3. So what is 3? Is it real? Yes. Is it rational? Yes. It is an integer, natural number, a whole number, and definitely not undefined, right? And then the most interesting one I've been waiting for. We have the square root of negative 16. What did I say about square root of negative numbers? They are non-real. It's not a real number. Why? Because non-real numbers have square root of negative numbers. They do not exist, right? So it is non-real, meaning it cannot be rational, irrational, integer, natural, whole, or undefined, right? I hope everybody understands me. Next one, we have 7 over 0, or 7 divided by 0. What did I say about any number divided by 0? It's undefined, right? Cool. So we'll just cross all of this out. Hope everybody gets it. And then we have square root of cube root of 27. Please punch it into your calculator. What is cube root of 27? It is equal to a negative 3, isn't it? So a negative, and then we have a decimal number, 0.5432, and so on, with a pattern that is not repeating, with a decimal is not terminating. So just like pi, it is what? It is real, but it is irrational, right? So it is a real number because it is a decimal. Cool. But is it a rational number? No, it is irrational. So we cross all this out. And the last decimal that we have 0.646464 and so on indefinitely. There's a repeating pattern, isn't it? So is it real? Yes. Is it rational? Yes, it is because it has a repeating pattern. Meaning it cannot be irrational. And we cross all this out. I hope you all understood the real number systems and how we can group the numbers together, whether they are rational or irrational or non-real numbers. So if you have any comments, please comment down the comment section. And please don't forget to like, don't forget to subscribe, don't forget to share. I love you so much, guys. See you on my next video. Bye.